And y'all, that's mainly all that 8.3 is going to be covering tonight. And this is polynomial division. And I'm going to go through the steps again when I do a problem. But let me say this. So the only polynomial division we're worried about tonight is what we call synthetic division. And I use synthetic division for three things. The first thing I can use it for is finding function values. Second thing I'll use it for college algebra, is testing whether a number is a zero. And then the third thing I use it for, you'll see in the support section, and I'll do one of those kind of problems, is finding the quotient and remainder. Okay, so that's three things I can use it for. Finding function values we'll go over first. So finding function values. So we got a little property in math that tells us, and we call this the remainder theorem, but the remainder theorem tells us that the remainder from doing synthetic division is equal to the function value for a given number. So if I use synthetic division to find function values, we're going to get a remainder in that little box like I showed y'all the other night. That'll give us the function value. So let's do an example doing that. So y'all, we're going to use synthetic division to find the function values. Now, the polynomial, they're giving me f of x equals x to the third minus 13x squared plus 52x minus 60. Now, for this problem, they want me to find f of 2, f of a negative 5, and f of 6. Which means I'm going to do my synthetic division 3 times. First, I'll start with the 2, get that function value, then the negative 5, then the 6. All right, y'all, so I'm going to write my steps over here in case y'all didn't get them the other night. All right, y'all, let me let 2 in real quick. Okay. All righty. So the first thing I do is I write out the coefficients of the polynomial. Now here's the thing. You got to start with the highest exponent and make sure all the terms are here. So I got my x3 term, my x squared term, my x term, and my number, which we call the constant term. If any of these were missing, I would have to use a zero. So I'm going to write that down. Use 0 for any missing terms. So if this didn't have a 13x squared here, my second number would be a 0, okay? You gotta put placeholders if any of your exponents are missing from that descending order. So nothing's missing here. So we're going to write out the coefficients first. So there's nothing in front of the x3, which means that's a 1. In front of the x squared is a negative 13. In front of the x term is a 52. And then my constant term is a negative 60. So we've written out our coefficients. Next, I'm going to draw a line. Draw a line, leaving space under the coefficients. And then I'm going to box under the last number. So y'all, all I mean by that, I'm going to draw a line right here. Notice I left a little space in between. And then I'm going to box under the last number. This box is going to be what we call our remainder box. But remember, since we're using it to find function values, the remainder that's in this box will be equal to the function value, okay? Now, next, we write C. So I'm going to put a little half of a box over here. This is what we call our C. And C is basically what we're dividing by. Okay, so write C to the left. Now, C will equal each of these numbers they're wanting me to find the function value of. 2, -5, and 6, which means the first C I'm going to use is a positive 2. When you're finding function values, the C will keep the same sign as the number you're looking for, okay? All right, now we're ready for our synthetic division. So the first thing I'm going to do, you bring the first number down below the line. So bring first number down below the line. All right, so I brought my first number down below the line. Now, what we're going to do, we're going to put a number under that negative 13. And then we're going to do a process here. So to get what number goes under the negative 13, I take the number I brought down. So take the number you brought down. And multiply by the C. So we're going to multiply by C, which is 2. Once I get that answer, we're going to put the answer into the next column. Okay, so watch. It's going to go under that negative 13. So we're going to multiply the number we brought down by C, which is 2. So 1 times 2 is 2. Next step, We're going to add that column and bring the number below the line. Add the new column and write answer below the line. All right, so I'm going to add negative 13 and 2, which gives me a negative 11. Now, at that point, I'm going to repeat this process until I'm done. So repeat until done. So the number I brought down, now this negative 11 is going to get multiplied by the C to go to the next column. So let's see, negative 11 times 2 is negative 22. We're going to see what a 52 and a negative 22 give us and bring that number below the line. So what's that? That's going to give us what, 30? So now that 30 is below the line, I'm going to multiply by 2 and bring it to the next column. So 30 times 2 is 60. Once we add this last column, we will have what f of 2 equals. And y'all look at that. 60 and negative 60 gives me a 0. So that means if you plug a 2 into this polynomial for those x's and did all your order of operations, it's going to equal 0 when you're done. So y'all, here we go. F of 2 equals 0. Now they want me to find f of negative 5. So I'm going to use the same coefficients on this one. 1, negative 13, 52, and negative 60. I'm going to draw my line and put my box under the last number. This time our C, we said, was negative 5. All right, y'all, so here we go, the first number, bring it down below the line. So I brought my 1 down. Now we start our process. 1 times negative 5 is negative 5. Now, I'll tell you where I get people is when you're doing the adding and subtracting, gets more people than anything. 2 negatives when you add will stay negative, okay? Remember, like signs, add and keep their sign. So a negative 13 and negative 5 is a negative 18. Now, I'm going to start repeating my process. So what do I got? I got a negative 18 times negative 5. That's going to be a positive 90. Okay, so remember, multiplying 2 negatives, make that a positive. Now, add that column. So it looks like we're going to get 142. And y'all got to do this one more time. That 142 times that negative 5 is going to give me a negative 710. So now when we add those, we will know what negative 5 equals. So y'all, let's see, that's what, negative 710, negative 60. Looks like a negative 770. So we would write f of negative 5 equals negative 770. And then we get to do it one more time with the 6. All the coefficients are still the same. 1, negative 13, 52, and negative 60. We're going to draw our box, or line with our box. And we said we're finding f of 6. All right, y'all, so who wants to lead me through this? Do y'all want to try it? All right, so y'all are going to say, hey, bring that first number down below the line. So that's why I'm drawing these arrows, bringing that 1 down. All right, y'all, now we're just going to multiply and add until we're done. 1 times 6 is 6. Negative 13 plus 6 is a negative 7. All right, negative 7 times 6 is a negative 42. 52 and a negative 42 is a positive 10. And y'all look at this. 10 times 6 is 60. So negative 60 and 60 give me a 0 again. So that means f of 6 also equals 0, just like f of 2 did. All right, also, synthetic division is not bad once you learn that process. Bring it down, multiply, add, multiply again, add, until you're done, okay? All right, question on that. All right, y'all, so let me show you examples of the second thing I use it for. Remember, I said I can also use it to check if a number is a 0 of a polynomial. So let's write a little note about that. So if a number is a 0 of a polynomial, then the remainder from synthetic division is, well, think about it. If a number is going to be a 0 of a polynomial, that means when I do all this synthetic division, that remainder better be 0. Now, if you get any other remainder other than 0, that means that number is not a 0, okay? Now, this is important if you're ever graphing polynomials, because remember, the zeros are where it's going to cross that x-axis at, okay? So we're not going to have to graph these right now. So what we're going to do, we're just going to determine if a number is a 0 or not. So for this example, they say using synthetic division, determine whether the numbers are zeros of the polynomial. So the way they write this, they got negative 3, comma 2, and then they say f of x equals 2x to the third plus 3x squared minus 5x plus 12. Okay, so they want me to check negative 3, see if it's a 0. They want me to check 2, see if it's a 0. So this will be like a yes, yes, no, no, yes, no, no, yes type answer on this one, okay? And you got to put them in the order that they give them to you. So we got to check that negative 3 first. So first of all, we got to write our coefficients. So let's see if anything's missing. I got the x3, I got my x squared, I got my x to the first, and I got my constant term. So nothing's missing. So write your coefficients. 2, 3, negative 5, and 12. Draw our line under it with the box. And then over here will be our C. And C is basically the number we're checking on this one, okay? So the first C I use will be the -3. Now, all I'm looking for is, am I going to get a 0 or not? Okay, 0 is yes. Any other number? No. So y'all, here we go. The same thing. Bring the 2 down below the line. And then we're going to multiply, add, keep multiplying and adding until we're done. So 2 times -3 is -6. 3 and a -6 give us a -3. Y'all, let's see what we got here. -3 times -3 is 9. -5 and 9 give me 4. And y'all look at that. 4 times -3 is -12. When I add them together, I get a 0 remainder, which means, yes, -3 is a 0 of that polynomial. So now we got to check 2. So 2 will be my new C. My coefficients are still going to be 2, 3, -5, and 12. All right, let me get that boxed up. All right, so now, same thing. Same process as we did. Bring the 2 down. 2 times 2 is 4. Bring that to the next column. All right, let's add that. What's that? 3 and 4, 7. Multiply. 7 times 2 is 14. -5 and 14 give me a 9. And y'all look at this. 9 times 2 is 18. Well, since I didn't get a -12 on this, I know this ain't going to give me a 0. So if I add that, I get 30. So since I did not get a 0 there, this answer would be no. So in Math Lab, they'll have you go through the answers, and you sort of said, you say like -3 is a 0 because the remainder was 0. 2 was not a 0 because the remainder was 30. So you sort of got to tell it why it is or why it isn't, okay? All right, y'all, question on this yet? All right, so I'm going to do one that's got like the last one will be for you. So y'all watch this one. This one says, and we're still going to find whether a number is a 0 like we just did here. So using synthetic division, determine whether a -3/2 is a 0 of f of x equals x to the third plus 5/2 x squared plus 13/2 x plus 15/2. So look at that. I got fractions running everywhere on this one. So let's see. I got my x3, I got my x squared, I got my x, and I got my number at the end. So nothing's missing. So we're going to write a 1 for the x3, 5/2, 13/2, and then 15/2. Those are my coefficients. So let me draw my line. I'm going to make it a little wider this time because I got fractions here. Just in case I got to throw fractions in here, okay? Now, our C they gave us was a -3/2. Now, the one thing I will say, we're lucky, everybody's got a common denominator. Fractions ain't bad if you got a common denominator, okay? All right, y'all, so here we go. We're going to bring the 1 down. 1 times negative 3/2 is a negative 3/2. So y'all, remember, when you subtract fractions, 5/2 minus 3/2, you got a common denominator, so the bottom is going to be a 2. So all we got to do is figure out what the 5 minus 3 will give us. Well, 5 minus 3 gives me a 2 on top. And y'all look at that. 2 over 2 will reduce to a 1. So 5/2 minus 3/2 gives me a 1. So then I do that again. 1 times negative 3/2 is negative 3/2. So let's see what 13/2 minus 3/2 will give us. Once again, they got a common denominator, so the bottom will be a 2 at this point. What do we got? 13 minus 3 is what, 10? But y'all look at that. 10 divided by 2 will turn into a 5. So that gives me a 5. So the trickiest part on this is going to be multiplying 5 times negative 3/2 to see what we get here. So I got 5 times a negative 3/2. Now remember, this whole number can be made to look like a fraction by putting a 1 under it. I always do that because remember, fractions multiply straight across. So 5 times negative 3 gives me a negative 15. 1 times 2 gives me a 2. Can't reduce that, so I'm going to put that right here, negative 15/2. But y'all look at that. 15/2 minus 15/2 gives me a remainder of 0. So since I got a remainder of 0, that means negative 3/2 is, yes, a 0 of that polynomial. No, it's not fun. I love this stuff because once you figure out them little, the process, it's one of the best ways to check for zeros and stuff. All right, so let me show you one like you'll see in the support. I think support has 3 of them, so I'm going to do one of these. Now remember, support, I'm going to use it to find the quotient and remainder. So for support, they want me to use synthetic division to find the quotient and remainder. So they're giving us a to the third minus 4a squared plus 9, and we're going to divide that by a minus 2. Now, I'm going to show you 2 ways they might write these answers, okay? All right, check this out. First thing, I'm going to write the coefficients of this first polynomial. But look here, I got an a3. I got the a squared. But y'all, we're missing the a term here. So since there's no a term, we got to put a 0 there. And then our 9 will be at the end. So our coefficients are 1, negative 4, 0, and 9. So my a3, my a squared, my a, and my number. Then I'm going to draw my box. So over here, the first thing I'm going to say is I use a 0 for the missing a term. Okay. Now, here's the second thing about this, or C on this. Since it's in factored form, the C will be opposite the sign of this number. So since this number is a -2, our C will be a +2. So since in factor form, C has an opposite sign than the factor.
And where did you find the 2 again? The C?
Oh, because see, this was a -2. So since we're dividing by this factor, this is the number that we changed the sign to make a 2.
Okay, that makes sense. Thank
Okay.
you.
And if you remember when we were finding zeros last class, when we had them all factored out, if you remember when we got our answers, they always had opposite signs. Like if y'all had an x -4 as a factor, we always ended up getting like an x equals a +4. So this is sort of going off of that principle, that the numbers you're checking are always going to be opposite signs than these factors, okay? Now, remember, this box here is going to be the remainder. All these numbers under this line will be the quotient part of it. So let's see what we get in all this. So you remember the first step, I'm going to take the 1 and bring it down. All right, what number's going under that -4? What y'all think?
2.
It's going to be a 2. Good job. 1 times 2 is 2. So now we're going to add, let's see, what, -4 and 2. That's going to give me what, a -2. All right, and then keep going, right? -2 times 2, -4. 0 and -4 give me -4. And y'all finally, that -4 times 2 is -8. So it looks like my remainder is going to be a 1. So y'all, let me show you. This part right here, these 3 numbers, we're going to get our quotient from. This 1 over here is my remainder. So here's the thing on this. The quotient starts 1 degree less than the original polynomial. So that means since I had an A3 on my original polynomial, 1 degree less means that this is going to be an A squared here, an A here, and then my number at the end with a remainder of 1. Okay. If you had an A5 here, then your quotient would start with an A4. Remember, the degree is the exponent that we're looking at, okay? So 1 degree less, let's write that out. That would be 1A squared. So we got 1A squared minus 2A, and they always go in descending order. And then at the end, it'll be that -4. And then I got a remainder equal to 1. Now I'm going to show you another way they write this, okay? Because this is one way they write the quotient and remainder. The other way, they write it like one big polynomial. Now, I'll show you what they do. The first part stays the same. A squared minus 2A minus 4. But instead of saying remainder equals 1, since this 1's positive, they do plus 1 over the A minus 2. Sort of like long division when you got a remainder and you put it over what you divided by. They're sort of doing it that there'll be one, I think, where you got to do it this way and they give you like an A, B, C, D choice. But all you're doing is putting your remainder over what you divided by, okay? So y'all, that's the three things I use synthetic division for. Function values. To tell whether a number's a zero or not, and to find the quotient and remainder when I divide. So now we get to start some fun stuff. Because y'all love foiling, right? Hopefully. So I'm hoping y'all like foiling for what we got coming up. So let me change my paper here. We're going to get a start on at least half of 8.4. And y'all, let's see, 8.4 deals with what we call theorems about zeros. So theorems about zeros of polynomials. So this first part starts out sort of going in reverse. You remember the other day, we got a polynomial and we factored them and we found zeros that way. Well, today we're going to start with the zeros and work backwards and come up with the polynomial. So let's work through one of these. So y'all watch this. Find the polynomial and we'll write out the steps as we're going through here. So find the polynomial function of degree 3 with the following or the given zeros. All right, so the zeros they're giving me are -2, 3, and -8. Well, remember this, we're going to work in reverse on this. So the first thing I do is I write out all three of these as a solution. Since -2 is a 0, that means that x equals -2. Since 3 is a 0, that means x could equal 3. Since -8 is 0, that means x could equal a -8. Now, if you remember to get to this point, we were moving numbers from one side because we had a 0 on the right side. So what we want to do now is get a 0 on the right side of each equation. Well, if I want a 0 on the right side of this one, I got to add 2 to both sides. So I'm going to come in here and add 2 to both sides. And that gives me an x plus 2 equals 0. Well, that makes sense. If the zero's a -2, the factor's got to be positive. And y'all, we're going to do that to these two. So this one's +3. So we're going to subtract 3 from both sides. And I get an x minus 3 equal to 0. And then finally, -8 means we're going to add 8 to both sides. And y'all look at that. I get an x plus 8 equal to 0. All right, so the next step we're going to do, write each equation in parentheses as a product equal to 0. Ain't it true? If this equals 0, this one equals 0, this one equals 0. If I write them all together, they're still going to equal 0. So we're going to come in and go x plus 2 times my x minus 3 times my x plus 8. All of these multiplied together still equal 0. Now y'all look at this. We got 3 things sitting here that are being multiplied. So it looks like we're going to start out by foiling. Now I'll tell y'all a trick I do on this one. To make it easier to foil, I foil the last 2 first. Now you can do the first 2, but I'll show you why I do the last 2 first. So over here on the side, let's foil the last 2 out. Let's foil the x minus 3 times the x plus 8. Because I'm just going to bring the x plus 2 down. And it's going to multiply by whatever I get right here, okay? So there we go. X times x is an x squared. X times 8 is an 8x. Negative 3 times x is a negative 3x. And y'all, negative 3 times 8 is a negative 24. And all we got to do now is add the like terms in the middle. So you're bringing down your x squared. Oh, what do we got? 8 minus 3 gives me, what, a positive 5x. And then minus my 24. So I can't do nothing else with that. So I'm going to put that in my parentheses. X squared plus 5x minus 24. And all of this is still equal to 0. Now, the reason I do the last 2 first is because this always gives me 3 things. And now I can just distribute these 2 by all 3 of these. It's sort of trickier. If you do the first 2, then you have 3 first and then the 2. Either way will work as long as you multiply this times all of that and this times all of that, no matter which way you go, okay? Now remember, they told me I got to end up with a degree 3 when I'm done, so that means the highest exponent when we're done has to be a 3. So 3 zeros, the highest exponent of 3, okay? So this x is going to multiply by all 3 of these. So x times x squared is x cubed. X times 5x is a 5x squared. X times negative 24 is a negative 24x. So that takes care of the x being distributed. Now we're going to do the 2. 2 times x squared is a 2x squared. 2 times 5x is a 10x. And then 2 times negative 24 is a negative 48. Oh, and y'all look at that. I got all kinds of like terms in here. So let me go in descending order. The x3 has nothing else, so bring it down. Next will be the x squareds. So let's see, I got what? 5x squareds, 2x squareds, and that's all. So that's going to give me what? 7x squared. Oh, let's see, I got x's are next. Negative 24x's plus 10x's. That's going to give me negative 14x. And then finally, nothing adds to the number, so bring down my negative 48. Now, check this out. The answer, they say, for the answer, f of x equals x to the 3 plus blank x squared minus 14x minus 48. So they're just looking for the polynomial. So out of this whole problem, I did it to find whatever number's going in front of that x squared. Okay? And y'all, I got the number right here. All I had to do on that was put me a 7 into that answer block. Okay, so that one they give you most of the answer. I guess, and that's just to see if you're on the right track or not. And actually this next one will too. So question on that. So y'all set the zeros equal to your x's and then get zeros on the right side. And then it's all about foiling, okay? All right, so let me ask y'all this. Are y'all familiar with your imaginary numbers? So we're going to write a polynomial. Whose zeros are 2, 4i, and negative 4i. They're giving me imaginary zeros this time, y'all. But that's cool. We can do that. But notice, they didn't tell me what degree I'll end up with. Well, y'all, I'll tell you what, the way that you'll know what your highest exponent's going to equal, it's going to equal how many zeros you got here. So I got 3 zeros, which means when I'm done, my highest exponent will be a 3, okay? And I'm going to give you all a little bit of refreshing on these imaginaries when we multiply here. So first, set them all equal to the 0 equal to x, right? So I know x equals 2, x will equal 4i, and I know x will equal a negative 4i. So I'm starting out the same way as a while ago, and I'm even going to get 0 on the right side of all of these by adding and subtracting. So here I'm going to subtract 2. That'll give me x minus 2 equals 0. Here I'll subtract 4i. That'll give me x minus 4i equals 0. And y'all finally add 4i on the last one. That'll give me x plus 4i equals 0. So we now have our 3 equations equal to 0. So now I'm going to write them in parentheses as a product equal to 0. So x minus 2 times x minus 4i times x plus 4i, and those will all be equal to my 0. Now, I will say this. On this one, I always start with these imaginary numbers here. Whether they're in the front or back, I'm always going to start with these, because you're going to see what happens when you foil these first. So we're going to foil the side over here. We're going to do a x minus 4i times a x plus 4i. So these always come in conjugate pairs. That's why one's 4i and one's negative 4i. Imaginary zeros always come in conjugate pairs, which means it'll be a negative and a positive of that I, okay? Now watch what happens on this one as I work through it. X times x is x squared. X times 4i is a positive 4ix. Now we're going to distribute this. Negative 4i times x is a negative 4ix. And y'all, how about this? Negative 4i times 4i is a negative 16i squared. What happens in the middle? You got like terms right there. But y'all, 4 and negative 4, they're going to cancel. Anytime you FOIL conjugate pairs, the middle will always cancel. So that leaves me with this x squared. But y'all, I'm going to show you something. Let's go to the calculator, and I'm going to punch in negative 16i squared to show you what happens to that. So let me share my calculator a second. So you see the little I down here by the decimal? So I'm going to put in negative 16. I'm going to hit the second blue button and the decimal to get the I, and then I'm going to square that. So I got negative 16i squared on the screen. Watch what happens when I hit enter. It become a positive 16. That's because I squared equals negative 1. So remember that. I squared equals negative 1. So if you got a negative 16 times that negative 1, it's going to make it a positive 16. What do you notice? The I is gone. Anytime you FOIL conjugate pairs of imaginary numbers, the I cancels out and it's gone totally. And they always end up with a plus in the middle, okay? Conjugate pairs of imaginary numbers always end up positive. So we're going to replace this with that. So bring down your x minus 2. And then we'll put in our x squared plus 16 and set it all equal to 0. So now you see why I started with that, because the i's canceled every time. And this is only 2 things times 2 things. So let's FOIL these and be done. So I'm going to take these and FOIL now. So x times x squared is x to the third. X times 16 is a 16x. Now the negative 2 times x squared is a negative 2x squared. And finally I got what? Negative 2 times 16 is a negative 32. There's only one thing I got to do to that, y'all. And that's get that thing in descending order. Because I got to put the x squared term before the x. So I get my x to the third minus 2x squared plus my 16x minus 32, all equal to 0. So for that one, what they did f of x equals x to the third minus blank x squared plus blank x minus blank. So at least they're telling us the signs, and we can verify our signs are right. All we got to do is put in the numbers. So I need a 2 here for my 2x squared. What's next? I need a 16 in front of my x. And then at the end is a minus 32. Okay, so on that one, they're going to give you a little bit of the answers. These first 3, they sort of give you parts of the answers, or the answers are like an A, B, C, D choice. All right, so remember, I squared equals negative 1. So any number in front of that I squared, and it's always going to be minus that number times I squared, okay? and it's always going to end up positive. All right, y'all, so the next thing we're going to FOIL, and I'm going to give y'all a little review on this as we go through it. So the same thing here. This one says find a polynomial of lowest degree with zeros of square root of 2, negative square root of 2, and 4. Oh, so on number 2, they threw the i's at me. This time they're throwing the radicals at us. So when we get to the multiplying, I'll show you a trick on these, okay? But do you notice they're coming in conjugate pairs also? A positive square root of 2 and a negative square root of 2. The other day when we did those square roots, remember we got plus or minus those numbers? So that's what they're doing here. Now I do know it'll be degree 3 highest. My highest exponent is 3 because I got 3 zeros, okay? So y'all, let's start the process. X equals square root of 2. X equals a negative square root of 2. And x equals a 4. We're going to add and subtract so that we get a 0 on the right side. So I'm going to subtract square root of 2 on the first one. And I get x minus a square root of 2 equal to our 0. All right, this one's negative, so we got to add square root of 2. So I get x plus square root of 2 equals 0. And y'all, finally, we're going to move that forward by subtraction. And I get x minus 4 equals 0. All right, everything's equal to 0. So now we're going to throw everything in parentheses. So x minus square root of 2, x plus square root of 2, and then x minus 4, all are going to be set equal to 0. So y'all, let me tell you this. Notice I got conjugate pairs here. I'm going to FOIL these first. Because you're going to notice something about this when I FOIL these radicals, okay? So let's go to the side. And let's FOIL that x minus square root of 2 times x plus square root of 2. Now, a very important part on this. A square root times itself equals that number. So square root of 2 times square root of 2 is going to equal 2 in the long run. Because 2 times 2 would give you square root of 4, but the square root of 4 is 2. So a radical times itself equals the number that was under that radical, okay? So that's going to be important in a second. So let's see what we get. X times x is x squared. X times the square root of 2 is a positive square root of 2 times x. Now we distribute that negative square root of 2 times x is a negative square root of 2x. And y'all, finally, a negative square root of 2 times a positive square root of 2 is going to be a negative. And I'll do a square root of 4 at the moment. Because 2 times 2 under the radical is a 4. But I know what that 4 is going to turn into, right? So let's see. Well, look here. What happens here? A positive square root of 2x, negative square root of 2x.
They cancel.
They definitely cancel. So I want y'all to notice 100% of the time, I don't care what's in here, whether it's radicals, imaginary numbers, that stuff all cancels out when you FOIL these, okay? So let's see what we end up with. How about that x squared minus square root of 4, which is 2. So y'all check this out. The imaginary stuff always ended up positive. When you FOIL radicals, they always end up negative. Okay? Now, we can't go no further, so we're going to replace the first 2 with that. So I got a x squared minus 2. And now we're going to multiply that by that x minus 4 at the end. And once we FOIL this, we'll be done. All right, y'all, let's see what we get. We know we got to end up with a 3 because those were 3 zeros. So this x squared times x, that's going to give me my x to the third. X squared times negative 4 is a negative 4x squared. All right, negative 2 times x is a negative 2x. And then finally, negative 2 times negative 4 is a positive 8. All righty, so let's see. They'll have, our answer will be f of x. And y'all look at that. This one ended up in descending order. I don't have any like terms. So x to the third minus 4x squared minus 2x plus 8. So if you just realize you're starting in reverse from the polynomial, you set it equal to 0, you factor it out, and then you just keep working backwards to get those answers. So we're starting from the answers going in reverse. All right, y'all. So I got a really fun one coming up. Oh, so y'all gonna love this one. Now y'all notice I've been doing degree 3s all day long, but watch this one. They say find a polynomial of degree 7 with, now check this out, -1, a 0 of multiplicity, where you at? 3. Then it says 0 as a 0 of multiplicity 3. And 1 as a 0 of multiplicity 1. Now, do y'all realize when I'm done, my highest exponent better be a 7 because they said it's going to be a degree 7. Okay? So, let's see what they mean by here. -1 is a 0 of multiplicity 3. That means -1 is the answer 3 times. So you're going to go x equals -1, x equals -1, x equals -1. Remember, multiplicity tells me how many times that 0 occurs. All right, what was next? 0 is a 0 multiplicity 3. That means x equals 0, x equals 0, x equals 0. And then finally, 1 is a 0 of multiplicity 1. So that means it happens 1 time. So x equals 1. Y'all realize we're about to do a lot of foiling, right? So on all of these equations, I need a 0 on the right side. But look, those 3 at least got a 0 already. So I just got to work on the other 3. So add 1 to each of these first 3. So that x plus 1 equals 0. X plus 1 equals 0. X plus 1 equals 0. So those 3 are done. Those 3 already got a 0. So I got one more. So we'll subtract 1 on this one. And I get x minus 1 equals 0. Now remember, these are like them single terms we were doing the other day. So I always write the 0 stuff first, these single ones. So you got an x times an x times an x. Then we got parentheses x plus 1, x plus 1, x plus 1, and then finally a x minus 1. All of this stuff equal to 0. All right, y'all. So what's another way I could write an x times an x times an x? So I'm looking for some kind of shorthand to write them 3 x's being multiplied. Oh, you are so quiet tonight. How about x to the third? Remember, x times x gives me an x to the third. So that'll be my first step, writing them like that. I'm going to bring everything else down. So on the side here, I'm going to FOIL 2 things at a time here. I'm going to FOIL these 2. And I'm going to FOIL those 2. So the first thing I'm going to do is bring down my x to the third. And then we'll see what we get when we FOIL these things out, okay? So on the side, let's start with the x plus 1, x plus 1. Now, these are not conjugate pairs, y'all. They are both positive. So stuff don't cancel when they're both positive, okay? You just get a lot of like terms in the middle. So here we go. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And then 1 times 1 is positive 1. I'm going to add my like terms so that I get an x squared plus 2x plus 1. I'm going to put that in my first parentheses. Now I'm going to figure out what's going here by foiling this stuff on the side. So we got an x plus 1 times an x minus 1. Y'all listen here. Those are conjugate pairs, which means the stuff in the middle is going to cancel on this one, okay? Anytime you got conjugate pairs, whether it's real numbers, radicals, imaginary, stuff cancels. So watch this. X times x is x squared. X times negative 1 is a negative x. 1 times x is a positive x. And then that 1 times negative 1 is a negative 1. But y'all look here. Those are canceling, right? So that I end up with a x squared minus 1. So that's going in my second parentheses. And I'll tell you this, conjugate pairs of real numbers are the same thing as radicals. They always end up minus in the middle. The only time you'll get a plus in the middle of conjugate pairs is if it's imaginary, okay? Woo, y'all look at this. I'm going to FOIL this next. So I'm going to come over here on the side again. Now I'm going to do the two things in the front because it's easier. So I'm going to do the x squared minus 1 times the x squared plus 2x plus 1. Remember, I can do those first because a times b is the same as b times a, right? All right, y'all, let's have fun. X squared times x squared is x to the 4th. X squared times 2x is a 2x to the 3rd. And then that x squared times 1 is 1x squared. All right, now we distribute that -1. -1 times x squared is a -x squared. -1 times 2x is a -2x. -1 times 1 is a -1. So y'all, let me see what I got. I do got stuff canceling on this right here. That x squared and -x squared right there are going to cancel. So let's see what's left. I got an x to the 4th plus my 2x to the 3rd minus our 2x minus 1. So I'm bringing down my x to the 3rd, and then all this stuff I FOILed gave me an x to the 4th plus 2x to the 3rd minus 2x minus 1. So all that's technically equal to 0. Now, remember, a degree 7. So when I'm done, I better get a degree 7. So I do this last because all I'm doing is multiplying this x3 times everybody. So y'all, x3 times x4, 3 plus 4 gives me an x to the 7th. x3 times 2x3 is a positive 2x. Well, 3 plus 3 is 6. x3 times -2x is a -2x. 3 plus 1 is 4. You got to treat that like a 1 there for that exponent. And then the x3 times -1 is a -x to the 3rd. So let's see, when we're done, they will have the f of x on this one. And we actually got to put in this whole answer. X to the 7th plus 2x to the 6th minus 2x to the 4th minus rx to the 3rd. So y'all, look at all the foiling you're doing tonight. I ain't lying, there's a lot of foiling, okay? All right, so are y'all seeing this a lot of foiling, okay? So let's do another one. Whoops. I'm gonna show you one that's it's really similar. But it had a fraction on it, so I wanted to show y'all what I did on that. So let me move this up. All righty, so this one. Now they actually tell me find a polynomial of degree 3. So we're happy it's a degree 3, so we're not going to foil as much as we did on that 7 we just did. With the following zeros of -1/3, 0, and a 5. All right, y'all. So degree 3, I got 3 zeros. So I know x equals negative 1/3. I know x equals 0. And I know x equals 5. Now, add and subtract, get me a 0 on the right side, which that one's already done. So this one I'm going to add 1/3. So x plus 1/3 will equal 0. And then here looks like we're going to subtract 5. So you get x minus 5 equals 0. Now remember, the single variable I always write first. And then I'm going to put in my x plus 1/3, my x minus 5, set all that, equal to 0. So on this one, I'm going to start and FOIL this. Because y'all at the end, these single x's, all you're doing is distributing them. They don't have to be FOILed. It's this stuff that's being added and subtracted that's always got to be FOILed, okay? So on the side, I'm going to do x plus 1/3 times x minus 5. Alrighty, y'all. So x times x is my x squared. X times negative 5 is a negative 5x. 1/3 times x is a positive 1/3 x. And then 1/3 times negative 5. Remember, that 1/3 times a negative 5. Treat the negative 5 like it's over a 1 and multiply straight across, and you get a negative 5/3. So that's going to be at the end, negative 5/3. So the trickiest thing on this one is those like terms. What does a negative 5 and a positive 1/3 give us? Well, y'all, you know what? We got calculators. If you don't feel like messing with finding common denominators and all that, go to this calculator right here and ask it what is a negative 5 plus a 1/3, which is 1 divided by 3. All right, I'm going to ask it what it is. It's going to give me a decimal, but remember, I'm going to turn the decimal into a fraction by hitting the math button and then hitting enter twice. So it equals a negative 14/3. So that means I'm going to have an x squared minus 14/3 x minus my 5/3 at the end. Whoops, I forgot to go back to my paper, y'all. All right, so I brought down my x squared. Those equaled negative 14/3 x, and then I brought down my negative 5/3. So I'm replacing the stuff here that I FOILed with that. X squared minus 14/3 x minus 5/3. So the hard part on that one's done. All we're going to do now is distribute that x. So x times x squared gives me an x to the third, which I needed, remember, because they told me I had to end up with a degree 3. All right, the x times negative 14/3 x is a negative 14/3 x squared. So you're basically just adding the x to everybody. X times negative 5/3 is a negative 5/3 x. All equal to 0. So we're looking for the one they got that says x to the third minus our 14/3 x squared minus our 5/3 x. Okay, now they'll throw that's the multiple choice one. And two of the answers they had x squareds in the front. Well, x squareds are not degree 3s. It's got to be one of those that's got an x3 in the front, okay? And let me see what did they do to that. Oh, the only thing they changed was the signs on some of the answers, okay? All right, y'all. So the last thing I'm going to show y'all today is just a little. We're not going to be foiling for a little bit now, okay? But it's a little. It's what we call little properties about. So properties about zeros. So the first property, imaginary zeros always come in conjugate pairs. So what do I mean by that? That means if 3i is a zero, then negative 3i is also a zero. It also means if something like 2 minus 7i, if 2 minus 7i is a zero, then 2 plus 7i is also a zero. So if they're written as a complex number like that, all I'm changing is the sign in front of the I stuff. Okay? So 2 minus 7i, 2 plus 7i are conjugates. A 3i and a negative 3i are conjugates. Well, guess what? Radical zeros always come in conjugate pairs. Okay, so the radicals, that's why they gave us that square root of 2, negative square root of 2 while ago, because they always come in conjugates. So what that means, if square root of 5 is a 0, then a negative square root of 5 is also a 0. What if they got something like this? If, how about if 8 minus square root of 3? If 8 minus square root of 3 is a 0, then 8 plus square root of 3 is also a 0. Notice, the only sign that changed was the radical stuff. The 8 did not change signs. Just like up here, the 2 didn't change signs, only the I stuff, okay? So why do we got to know this? Well, y'all watch this example. So suppose a polynomial degree 4 and y'all, these are the last few examples I'm doing, going over this kind of stuff. So suppose a degree 4 polynomial has the given numbers as some of its zeros find the other zeros. So y'all, let me show you the numbers they're giving me. They're giving me a negative 5 as one zero. They're giving me a square root of 5 as a 0. They're giving me a 7/4 as a 0. So the question of the day, who's going to guess that for me? I need one more 0. And it goes by what we just said up in here. All right, where y'all at? Am I on here by myself? Anybody online?
Huh?
Okay, I just making sure y'all were there.
We here.
Yeah, we here.
Oh, y'all don't want to guess what my other zero is? Well, let's see. I don't have no rule about -5s. I didn't even have a rule about 7/4. But didn't I have a rule about these square root of 5s?
Yes.
Okay, because right here it says, oh, the square root of 5 is a 0. Then that means
It's 0.
a negative square root of 5 is also a 0. That's what they mean. If they give you this as some of your zeros, this automatically has to be a 0 because these always come in conjugate pairs, okay? So now that y'all know that, this one's on y'all. All right, so suppose a polynomial degree 4 has the following zeros. It says find the other zeros. And they got 0 with the S in parentheses because they could either be 1 0 or more zeros. So let's see what the numbers are they're giving me. They're giving us -I and 7 minus a square root of 11. Now that's one whole number right here, okay? And that's a single number, that -I. So if they're giving me 2 zeros and I got a degree 4 polynomial, that means 2 zeros are missing because they only gave me 2. So y'all, what's my other 2 zeros?
Is one the square root of the square root of 11?
But it's going to be 7 plus square root of 11.
Okay.
What's the other one?
Positive I?
Oh my God, there you go, positive I. Right? If you got a negative I, you need a positive. And then remember on these, since that's one whole number, all you did was change the sign of that radical. So y'all getting an idea of these now?
Kinda.
I got another one. Don't worry. Let me pull that camera back up. All right, so again, it's suppose you got a degree 4 polynomial. Has zeros of 2 plus 5i and 5 plus square root of 2 as some of the zeros. Find the other zeros. All right, so they gave me 2 zeros. What's the other 2? Well, let's see. I got a 2 plus 5i, which means one of them is going to be 2 minus 5i. And y'all right here, you got a 5 plus square root of 2. So the other one will be a 5 minus square root of 2. Okay? So if they give me i's and radicals, then I got to know where to put them, okay? So do you want to see why you learned this stuff so that you can do a problem? And I'm going to do one more when we got a foil. Oh, I'm going to do the harder one of the two. Find a polynomial function of lowest degree that has zeros of square root of 5 and 5i as some of its zeros. Now, they didn't tell me the degree because they don't want to give it away. But here's the thing. They're giving me at least two of them. They're telling me x, we know x will equal a square root of 5. But hey, if this is a 0, then what else has to be a 0 for sure? Well, x equals a negative square root of 5. So y'all, they gave me some of the zeros, but you got to know if they give you square root of 5, a negative square root of 5 will be there also. Now I got x equals 5i. Well, guess what? If 5i is a 0, then negative 5i has to be a 0 also because they come in conjugate pairs. All right, so let's get a 0 on the right side by adding and subtracting. So minus square root of 5 on the first. I get x minus square root of 5 equals 0. Here, I will add square root of 5. X plus square root of 5 equals 0. Here, I'll subtract 5i. And I get x minus 5i equals 0. And then finally, I will add 5i. So I get x plus 5i equals 0. So all this information was just so that y'all would know if I give you radical and imaginary zeros, then their conjugates are also zeros, okay? All right, now, and I'm going to show you how to do some shorthand foiling on this one. But I'm going to put everything in parentheses. All equal to 0. And guess what? These two are conjugates, so I'm going to foil them together, and I'm going to foil them two together. And then I'll just foil them here since I'm just foiling two things at once. So my first parentheses. Now watch this. We're going to shorthand this stuff. We're going to multiply the x times x and then the square root of 5 times square root of 5. We're not foiling this out because the middles are always going to cancel anyway. So the way to do these the quick way, x times x is x squared. Negative times positive is a negative. Well, square root of 5 times square root of 5. We'll do it like this, is a square root of 25. We'll simplify that further on my next step. All right, conjugate pairs, I'm going to shorthand. X times x is x squared. Negative 5i times 5i is a negative 25i squared. Now we're going to simplify these before we foil that final answer. So this will give me x squared. Well, remember, square root of 25 is 5. So that goes back to my property. Square root of 5 times square root of 5 equals 5. Now here, what did we say I squared equaled? So recall, I squared equals negative 1. And if you punch in negative 25i squared on the calculator, it's going to give us a positive 25. So that this negative 25 times negative 1 is a positive 25. Remember, the radical stuff always comes out minus. The imaginary stuff 100% comes out positive, okay? All right, y'all, so the radicals are gone, the i's are gone. Let's FOIL this and be done. X squared times x squared. So let me write that. I'm going to FOIL that now. X squared times x squared is x4. X squared times 25 is 25x squared. Negative 5 times x squared is a negative 5x squared. And then negative 5 times a positive 25 is a negative, 125? All equal to 0. So let's see. Ooh, I got like terms on this one. So I get my x to the 4th. 25x squared minus 5x squared is what, 20x squared. And then bring down my minus 125. So y'all, look, this will get you through up to 11. So for 8.4, work up to problem 11. We're going to come in Monday and start with the stuff around 12. And the stuff after 12, we'll start doing more synthetic division on those problems. But I wanted y'all to get all the FOILing stuff out of the way because this is some tedious stuff on some of this. And since 8.3 wasn't too bad, try to get all your FOILing out of the way if you can before next week, and that'll keep you on a good pace. Okay? So y'all, this is definitely going to get you strong at your FOILing for sure. Because if you notice, that's all I did tonight was FOIL, okay? So y'all, let me see. And that'll leave us probably, let me see. About 6 or 7 left in 8.4. And then we'll get into the next section on Monday, okay? I'm gonna stop my share. Oh, this one, it's already like 7:40. So this will be a long one. It might take it a little longer to download for me tonight.